Nonetheless, before we get to the math part of today's warm-up, I'm going to talk a little bit about gardening, simply because we're all stuck at home and food has become annoyingly hard to find because of people hoarding. Gardening is fun and easy. This is a set of beans that I'm trying to germinate right now by the paper towel method, which is to say I have a little container here and I took some dry beans and put them in here and sprayed it with a little bit of water. Not so much that it's like soaking wet, but just so that it's like, you know, damp the way that the soil is right now outside with it raining the way that it does in the spring. None of these have sprouted roots yet, but down here, oh, there's one.
Oh, cool.
This guy has sprouted a little bit of a stem. So this guy will be ready to go into the ground pretty soon. And so the reason why I want to talk about this is that certain plants, especially like beans and peas, are easy to grow. And so in a week or two, once they have fruit, instead of going to the grocery store and waiting in a super long line for, you know, green beans, I will already have them. This plant is only 5 days old and it's already that big.
Wow.
And you'll notice here on the side, I'm going to lift up this top leaf here. Those down there are the beans. They themselves get split, and then one side grows up, becomes leaves. The other side grows down, becomes the root. And so this guy right here will be producing new fruit in about probably 2 weeks, and it'll be making even more beans, you know? Was there a question out there?
No, I just said that's cool.
Oh, okay. And so let me show y'all my garden. Oh, can't be minimized. Wait, hold on.
Well, Mr. Robinson, for this first item, there could be 2 answers, right? Because it's quadratic.
Only one of them will make physical sense, but there are 2 mathematic answers to the quadratic, yeah.
Okay, got it.
Okay, so y'all see the PowerPoint?
Yeah.
Yeah, so that's my balcony garden. Can you see my mouse pointer over it?
Yeah.
Okay, so this is just the easiest way I found to like share a bunch of images with y'all. So of these 2 pictures here on the left, that's my like tiny bean farm. And you'll notice I put a bunch of like little, like a trellis up around it with some strings. Plants that crawl, if they have something to grab onto, they grow way quicker than if you just let them grow as a bush. So if you are gonna take some beans and try and grow them, highly recommend giving them something to grab onto. And the one on the right there, that's like my little table that I have of growing plants at home right now. There's a pineapple that I'm growing. This one here is gonna be an avocado tree. This is just some like thyme. And then in the middle here, I just wanted to show y'all that you don't need pots to have a potted plant garden. You can just slash open the bags of soil themselves and grow them right in there. And then the thing around it is just an IKEA bag to like stop the water from draining out. And then here are some other plants that I'm currently growing. On this second slide, that one on the left there is peas. And even though those peas are big and they've crawled in fairly far, those pea plants are only about 6 days old and they already have flowers. And as you know, flowers eventually become fruit. And then the one on the right is a jalapeno plant. That one's a lot older. That one's a year old. But now that it's a year old, it actually is constantly producing new jalapenos. So all of our food is spicy and I don't gotta wait in line at the grocery store. It's amazing. So just in case y'all wanna get started with gardening, which, you know, we have all this time at home, food is annoying to find at grocery stores right now. This is like a great hobby to pick up. Here's just a little bit of the basic information that you need. The country is separated into various growing regions. And you'll notice that we're in the orangey red area, which means we're in Los Angeles, somewhere in between Zone 8 and Zone 9. Every single one of these regions allows for the growing of different kinds of plants at different times of year, depending on what region you're in. And so if I go down to my zone chart, this is the zone chart from some company for Zone 8. What this tells us is that for these specific plants, if you want to get the most yield possible, certain plants are best planted in February, which is the green part of that bar chart. And then after you get them started indoors in the green part, then you move them outside to planters or straight up to your garden if y'all have lawn space. That's the orange part. And then for the red portion, they'll be producing food. So you'll notice the ones here that are really short grow the quickest. Carrots are quick, kale is quick, lettuce is quick, peas are very, very quick, which is why I'm growing them. And so of all times to pick up gardening, you're stuck at home and the grocery store is annoying to access. So you might as well learn now, right? Just a thought in case you're bored and you're looking for something to do when you're not sitting at your desk watching your teachers awkwardly on Zoom. Are there any questions there about gardening or whatever? If y'all want references, I could always post them in Classroom. No?
Sure, do it.
Okay. So let's go ahead and get started with today's warm-up. What's my proportion for part 1? What fraction do I need to write to solve this?
I put x over x plus 1 equals x plus 3 over 14.
Yeah, that would work. Yeah, so this part over this part and this part over this part, that's fine. You can go left to right.
Yeah,
you can also
go
top to bottom. So I'm just going to do it top to bottom just because I think that's a more visual look at this, because like the proportion's already actually here. So this is just going to be x over x plus 3 is equal to x plus 1 over 14. Now I'm going to cross multiply, yeah?
Mm-hmm.
And what do I get when I cross multiply?
14x equals x squared plus 4x plus 3.
On the left hand, so x times 14 pretty clearly gives us 14x on one side. But on the other side, this is going to be equal to x plus 1 times x plus 3. We have a binomial times a binomial. So in order to get the correct product here, we're going to have to FOIL first, outer, inner, last. And so the left-hand side is going to give us x squared plus 3x plus x plus 3 is equal to 14x. And so the left-hand side is going to simplify down to x squared plus 4x plus 3 is equal to 14x. And now how do I solve this?
You have to do minus 14x from both sides, so it can be equal to 0.
Whenever we have a quadratic, it's going to be x squared, and we're going to try and set that other side equal to 0. So I'm going to subtract 14 from each side. X squared minus 10x plus 3 is equal to 0. And now I am looking for two numbers which multiply to negative 10, but are different from each other by positive 3. Can anybody think of a pair of numbers?
Negative 2 and 5.
X and 2, x and 5. So just so y'all know, when we play the factoring game, these have the correct difference. They're different by 3. And they have the correct product. They multiply to 10. However, here's how we figure out what their signs are for those of y'all still practicing this skill. I know that one of them has to be negative because a negative times a positive will give me back a negative number here in the middle. But I need the difference to be positive. So which one of them is the negative number?
The 2.
X minus 2, x plus 5 makes it so that negative 2 times 5 gives us negative 10, but negative 2 plus 5 gives us positive 3. And so of these two values, I can take and I can set each one equal to 0. So x minus 2 is 0, x plus 5 is also 0. And so x is equal to 2, x is equal to negative 5.
There's two answers.
And so which one of these is a good physical answer?
2.
I think it's the 2, yeah.
Yeah, it's got to be this one simply because we don't want negative lengths. This may work out algebraically, but it doesn't work out physically. So if we go back up to our diagram, that gives us enough information to fill out this whole puzzle. So that means that this guy is 2, and this guy is 3, and this guy is 5. Though obviously my diagram is not very much to scale. For this to actually work out this way, this line would have to be way more tilted than it is.
Wait, how do you know like whether to choose 2 or 5 or negative 2 or 5?
If I took negative 5 and I plugged it in everywhere, this length would be negative 5, this length would be negative 2, this length would be negative 4, and negative lengths are just unsettling.
Oh.
Is that first one okay?
Yeah.
Okay. Over here, item number 2, are these lines parallel, yes or no?
I
No.
said no.
Good. The answer is no. Let's go ahead and go over why real quick. When it comes to triangles, we want to use total lengths of the triangles in order to get our ratios. And so what we know is that if these two were parallel lines, it would make similar triangles, which would obey proportions. And so on the right-hand side, what's my proportion?
20 over
50.
yeah, 20 over 50.
So it's the side length of the little triangle versus the side length of the big triangle, 20 over 50. And if these are similar, then this would be the exact same ratio as what on the left?
25 over 35. 55.
Again, it's got to be the total length when it comes to talking about triangles. And let's go ahead and see if these two simplify to the same fraction. So on the right-hand side, this breaks down to 2 over 5. We just cancel the zeros. And then 25 over 55, what fraction does that simplify to if we divide everything by 5?
5 over 11.
Are these two fractions precisely equal to each other?
Nope.
They are not. And as such, because there is no proportionality, these triangles are not similar. And that's enough information to tell us that, well, AB cannot be parallel to CD, which we can show that by saying AB parallel to CD, and then we put a strike through the parallel symbol. Is there a question in the chat? I think I saw it pop up.
Yeah.
What's up?
There was these problems on the homework, and I looked on the worksheet, and it told us to do it, to set up the proportion this way. 20, I don't know if this works though. 25 over 20 and 30 over, would that be 30 as well? So you're not using the full length in a sense. It was telling us to use it that way, but I still got the same answer.
For triangles with parallel lines within them, it will still give you the same answer because it's the setup here. The reason why when it comes to triangles, I highly recommend that you set up complete lengths is that there are types of questions that can be asked where not doing that won't let you solve for X. So the two will produce the same proportion in the end, but there are cases that I can build out where not using the total lengths will not give you enough information to solve for X. So just for my benefit, when you deal with triangles, give me total length proportions, not partials. Okay, so this time is yours to work on the homework, and if y'all have any questions, just let me know. And if you finish the homework assignment and upload it to Google Classroom, you're free to go to lunch, and that's just the way we'll run it every day. So let me go ahead and look at the homework. Oh, I got 5 turned in already. Those 5 of you turned it in. Good. Do y'all have any questions on what the answers are?
Oh, no. Mr. Robinson, I have to go do something and I finished the homework. Is it okay if I leave?
Yeah, totally. Yeah, like I said, if you finish the homework, just like when we're in class, if you finish the work and you have other stuff to work on, feel free. If you finish the homework and turn it in on these workshop days, you're free to head out early.
Yeah, sorry. Thank you.
Are you able to show the solutions through here so I know if?
Yeah, that was what I was.
Make sure I did it correct.
I know it's not the world's most efficient thing, but I don't want to be posting copyrighted stuff onto my Google Classroom, so we'll just do it this way. Which ones did you want to know?
No, I mean, the homework was easy. I'm pretty sure I got it all correct. Just making sure. I mean, wait, is there a way to flip the camera then show you? Oh, yeah, here.
Mr. Robinson, can I see the answer to second?
Just tell me the number. I have the assignments out in front of me. Also, because of that insane setting that you have on your camera, it's just the Golden Gate Bridge anyway. Just what number are you asking about?
Oh, no, I know all of it. I was just...
What number are you asking about if you have a question?
Can I ask
No,
second?
it's no specific one. I'm done with the homework.
Okay.
That's it.
Can I know the answer for the second page, number 2, please?
What page number?
Page 25, number 2.
Answer is 9.
Okay.
Good.
And also number 5, please.
12.
Okay.
Any other questions out there? If y'all holler them out, I can solve them. Or if you just want the answer, I could just read that out also.
Yeah, Mr. Robinson, I finished my worksheet as well, so.
You don't have to ask. If you're done and it's in,
Okay.
I have Google Classroom open right now. I know who turned them in. If you have yours turned in, feel free to sign off.
Okay, thank you.
Get it right now.
Mr. Robinson,
Yes.
how would you solve number 1 on page 25, the second page?
We would set up a proportion to solve for number 1 on page 25, you said?
Yeah.
And there are a lot of different proportions that we could use. Here's one that I would recommend. 5x divided by 3x, long side divided by short side, can be set equal to, for the other portion of it, what would that same proportion be? Long side divided by short side?
X plus 12 over 12.
Yep, and then conducting this cross product will give you a quadratic that you can solve for the answer.
Oh, okay. Thank you.
Yeah, you're welcome. Did you have a question on the solving of the quadratic?
No, don't you just split it up into like x plus something plus x plus something and equal it to 0?
You will have to factor it, yeah. So I'll work it out here, but feel free to keep going with your homework and you could look back once you've made some progress.
Okay.
I'm all done with the homework, Mr. Robinson. See you tomorrow.
Yep, peace, see you tomorrow. So this is a quadratic, and this one would have 2 answers, but one of them is boring. So in the step that I have 3x squared is equal to 24x, technically that's telling me that one of my answers is 0. X being 0 is not very satisfying from a geometric perspective. So we divide both sides by x and keep solving. We get 3x is 24, so for that first one, x is 8.
But how are you allowed to just cross out the like power of 2?
In this step, what I'm saying here is that 3x squared is 3x times x, and this is equal to 24 times x. So if I divide both sides by x,
Oh.
on the left-hand side, one x cancels with an entire other x, and then on the right-hand side, all of the x's cancel.
Oh, okay, I get it. Thank you.
Yep, good question.
Mr. Robinson,
Mm-hmm.
I have a question for the one you just did.
Yeah.
How did you cancel out the square root? Like, how are you able to cancel out the x squared?
I'll go over it one more time. Let me switch back to my document cam to make sure I have the right one. So are you okay about how we got to the line 3x squared is equal to 24x?
That's what I want to know. How did you get there?
So the way that I got here was I took the original proportion and I cross multiplied.
Okay.
So 3x times x plus 12 produces 2 terms. 3x times x is 3x squared. 3x times 12 is 36x. And then on the right-hand side, that's going to be 5x times 12, which is 60x.
Okay.
So from here to here, I subtracted 36x from each side. 60 minus 36 is 24, giving me 3x squared equals 24x. And like I said, x squared is x times x. So 3x times x is equal to 24 times x. And in this step, I'm dividing both sides by x to just get 3x equals 24.
Okay.
Is that okay?
Yeah, thank you.
Now, technically, some math people wouldn't like what I've done here because this is deleting one of my answers. Here is the most correctest way that you should write this out. At this step, I should actually go aside here and say 3x squared minus 24x is equal to 0. And then what does this let me factor out?
The 24x?
Just x. So instead of dividing out x from both sides, I can pull it out and say x times 3x minus 24 And just like in the warm-up, if I have two things that multiply to 0, this is giving me two separate answers. This is telling me that either straight up x is 0, that's my answer if one of these terms is x. This other one is telling me that 3x minus 24 is equal to 0. And so 3x is equal to 24, x is equal to 8.
Okay.
Is that okay?
Yeah.
The only reason why I skipped this part here is because x equals 0, it just doesn't match the problem well. We would have two lengths that are 0, and we shouldn't get 0 for a physical length.
Yeah. Okay.
For number 4, is on the same page, is it 10 over 3?
Yeah, the answer is 10 over 3 or 3 1/3.
Oh, okay. And for number 2, if there's only 3 numbers, so how are you supposed to set up a proportion?
If all of those inside segments on part 2 are equal to each other, then that's giving you the scale factor for each one of those similar triangles. So for the smallest triangle to the next triangle, the scale factor has to be 2 to 1, because for the big triangle, that side length is twice as long as it is for the short triangle. And then for all 3 of them put together, that scale factor compared to the original has to be 1 to 3, because the original length is 1 unit, but for the biggest triangle, it's that length times 3. So those congruence marks can be read off for scale factors.
So how would you find x, though?
By setting up proportions. So for question number 2 on this page, let's say that you want to solve for the part, see where it says 2x minus 6?
Yes.
Here's what we'll do. I'm going to go ahead and say that that congruent length, just for the sake of argument, is the letter B. So for the smallest triangle, that side length is B. But for the bigger triangle, the one that contains 2x minus 6, how long is it?
It's 2b.
2b. And so I can set up an equal proportion for the other side. So for the other side of this triangle, for the short length, it's 12. And then for the bigger length, it's going to be that total. So it's going to be 2x minus 6 plus 12. What's 12 minus 6?
6.
So it's going to be 2x plus 6. And we don't need to know what b is to solve for x, because b divided by b cancels. B is irrelevant. So 1/2, a scale factor of 1 to 2, should be equal to the ratio of 12 divided by 2x plus 6. And then solve that for x.
But how'd you get plus 6 and not minus 6?
This is just like how on the other side, the total length has to be b and b. This has to be the total length, so this is just 12 plus 2x minus 6. 12 minus 6 is positive 6. It's the sum of the two lengths.
Okay, thank you.
You're welcome. Anybody else out there have any other questions? Anyone else out there have any homework questions? No? Okay. Well, as y'all run into them, just holler and I'll work them out on screen.
This is random, but do you see all of us on the screen at the same time?
Yeah, it gives me the entire class, everybody's login names.
Oh.
Mr.
Yeah.
Robinson, is it too late for teachers to put in grades for quarter 3?
Normally it should be by now. Normally they would be closed on, they should have been closed and assessed on Monday, but because of the emergency conditions that we're all now under, yeah, because of the emergency conditions that we're all now under, they're going to be held open until Friday. So it should be possible to still input some grades. So if you have late stuff or missing stuff, be sure to email it to your teachers correctly labeled as soon as possible so that we can get it in before our deadline.
Mr. Robinson, I have a question for number 6 on page 26.
Yes.
How would you do it? How would you have to set up a proportion, or like what would you have to do?
Oh, right. These are good questions, and I think it's only hard because you are missing the instruction given at the top. So what is the instruction at the top for all of those questions, 6, 7, and 8?
Line JH is a mid-segment of triangle KLM. Find the
Yep.
value of X.
It is a mid-segment, which is actually an idea from last section when we were talking about trapezoids. So let me sketch out what is meant by mid-segment, and then once you know what mid-segment means in this context, it'll be really easy to know what these scale factors are. So by saying that JH is a mid-segment, that means that it is connecting the midpoints of the side lengths that it touches. So here's our triangle. And here we know that this length is 30. And JH is this line here. So this is JH. And then we have some other line up there. Yeah?
Yeah.
So JH being the mid-segment, what that tells me is that this and this are congruent, that J is the midpoint of its own side, and H, I'm sorry, this isn't drawn very well to scale, is also the midpoint of its own side. So this is congruent to that. That automatically makes it so that this triangle here and this bigger triangle have to be similar because we have an S. Both of those triangles, both the different sizes, the big one and the small one, they both share this angle, right?
Yeah.
And they have this side, this angle, this side. They also have, for the big triangle, this big side, this angle, and this big side. So here's the deal. What is the scale factor from this little triangle to the big triangle?
By half?
By half, 2 to 1, right?
Yeah.
So this little triangle is exactly half the size of this big triangle. So for the big triangle, if that's 30, guess what 15 is?
The little triangle, which is X.
Right, so how much is X?
15.
Yep, 15.
Oh, okay.
Yep.
That makes sense.
Yeah, so it's all just hinging on the definition of mid-segment, and then you use SAS similarity.
Okay, yeah. Thank you.
What's the answer to number 3 on page 25?
X is 5, Y is 2.
How are you supposed to do that when there's two different variables?
You can't normally, but notice inside the diagram there's a congruence mark.
Mm-hmm.
So that means that 2x plus 4 is equal to 3x minus 1, and that's how you solve for x. And then to get y, you set up a proportion.
Oh.
Yeah, if that congruence mark, don't get me wrong, you're right. If that congruence mark wasn't there, then we couldn't get a numeric answer to x or y.
Yeah, okay, thank you.
Mm-hmm.
And number 6 on the same page, is it 3?
Yes. Y is 3. And hey, I guess I'll post the following announcement to Google Classroom. But instead, what I'm going to do about those like pirates who were on at the start of the stream, just to like, I mean, remember, Eric, this is going on YouTube. Choose your words carefully. I am actually just going to crop those people from the beginning of the video because I think reposting this to YouTube with their little outbursts removed will probably bother them more than me just like not posting this video at all. So thanks to them, I'm going to learn how to edit videos just so that I can crop that first 45 seconds. Here's what else is hilarious. Those people signed on with their Zoom accounts that they set up for school. So I have their names, right? I can still write up, what's it called when they take the good guy points away from you?
Participation points.
No, because they're not in my classes. What are the points that end up with the detention?
Demerits.
Right, demerits.
Oh, demerits.
I'm just gonna write those homies up demerits so that the first day we get back to school, once it reopens, they get to come hang out in detention. That'll be a good time. And hey, I'm just gonna make it real plain for the rest of y'all. The next time that happens, I'm gonna take points away from everyone's participation.
Oh my
So if
God.
one of you shares the Zoom link with anybody outside, know that it's going to come out of all of your grades. I think that's the simplest solution.
Didn't the California governor say that we're not starting school until next year?
That is a rule set for public schools, though if it is the official guidance, we will probably follow suit. And just based on science, the epidemiology of what's going on, the way that viral outbreaks work, that is probably what I think will end up happening in my amateur opinion.
Remember when you told us the chance of our school closing is 0? What changed that made it not?
So when I said the chance of the school closing is 0, what I meant is us just stopping.
Oh.
Not that we would close physical doors, but that we would give up on teaching. That won't happen. But what changed was the number of cases in nearby areas. And as soon as that crossed a certain threshold, we decided to close locally because there was not a larger order given down by the federal government to do that. And it was pretty obvious because I mean, you got to keep in mind that the college that closed first in the area was UCLA, and UCLA is not made up of dummies. Even though I graduated and I'm not there to argue with people, they have some of the smartest doctors and epidemiologists in the world doing research on campus. And those people who have been paying attention to the news are like, this isn't right, we need to close. So here's how you should think about these closures. On average, each person who has the virus is going to infect 2 people on average, which is to say that if you got sick and you just self-quarantined immediately and you just stayed at home for 2 weeks with cats, you would infect 0 people. But for every person who's doing it the right way, you have some person who gets sick and then they fly on an airplane where that person is probably going to infect 30, 40, 50 people who all then go to their own unique neighborhoods and each infect, 2 or 3 more people. So that average of 2, that is a huge aggregate, knowing that there's a bunch of people who infect 0, a bunch of people who infect 1, and your occasional rare case where somebody's going to infect 30, 40, or 50 because they traveled or went to the gym or some other high multiplication value activity in terms of this. Here's the danger and why everything is actually shut down. There is only a set number of hospital beds and ICU, intensive care unit beds, available in the country at any given moment. And if the number of sick people becomes greater than that number of hospital beds, then hospitals will have to triage people. And currently what is happening in Italy is they are giving ICU beds based on age. So if you're young, you get one of those beds. If you're old, you are sent away from the hospital to die. just because that's the way it is when you are conserving resources to try and help the most number of people possible and to extend the lives of people to the maximum amount possible. And so the goal of having everybody go home is to decrease the average. So instead of infecting 2 people on average, if you get the virus, hopefully we can get that number down to 1, or even better, below 1, as long as everybody does stay home and doesn't get each other sick. And that will slow down the infection rate. So instead of having to ration the hospital beds and just know that some people will die because they won't be put into ICUs, the goal is to try and keep the number of people who are infected low enough so that everybody who needs a hospital bed can get a hospital bed.
Is that why they're like flattening the curve or something?
That is precisely what that means. The idea is that the infection can play out any number of ways, but what doesn't really change is we have a fixed number of hospital beds, and maybe we can increase the number of hospital beds over time by having companies build them right now. Like it's happening as we speak. People are making more beds available. Also, the Army could be used to make additional hospital beds available. And so from day 1 of the infection, if we were to do nothing, the infection will infect a ton of people and last a really long time. And so everybody outside of this curve, these people will not have access to hospital beds. And those people will be sent out by triage, and there is no chance for those people. However, by sending everybody home, we hope to make this curve shorter, which has 2 effects. It will make it so that in a perfect case, we do not go above that line and everybody who needs a hospital bed can get a hospital bed. And also, if you flatten the curve, you make it end sooner so that the number of cases drops to 0 more rapidly. But this type of curve is something that you learn about in Algebra 2 and in Pre-Cal. This is in the chapter called exponentials because viruses cause exponential growth. And this specific type of exponential curve, who just drew on my screen?
Yeah, there's like.
Oh shoot, what?
I mean, you can annotate if you have a question to ask on the screen, which is a good thing to do, but yeah, careful with that. No,
Yeah,
it's
I
a
was
tight
just
feature.
experimenting.
Yeah, no, it's cool. No, it's a good thing to figure out because, we're going to be at this for a while, obviously. You might as well figure out how it works because if you're like, hey, Mr. Rob, what is this? Do me a favor, underline that with that tool you just used.
Okay. Let me go back to it. Annotate. Draw.
Yeah. So if you ever have a question, that's a good way to get my attention. Just be sure to remove it when you're done. I could remove it, but if I'm doing stuff with my hand's not on the mouse. Anyway, this is under exponentials, and this is a specific thing called logistic growth. And if you play with the variables that you plug into it, you get different types of logistic curves that play out over time. And the goal is to decrease the multiplying variable of the infection so that we don't overwhelm hospitals.
If we didn't have a flu shot and the flu were to appear now, would the same thing happen as corona?
So the same thing is constantly going on with the flu. It's just that we're so used to it and hospitals are so well set up for it that it doesn't cause a problem in hospitals. Though you should know every year, tens of thousands of people die due to the flu. You just don't notice it because you're young and healthy. You're surrounded by young and healthy people. The flu kills a lot of people every year. I don't want to quote an exact number and be wrong. It's either in the tens of thousands or hundreds of thousands. And just like the vulnerability group for the coronavirus is dangerous to the old, but the flu virus.
Mr. Robinson, I finished my homework. I'm gonna go, okay?
Give me 1 second. The flu kills on average, just regular old influenza, kills about 17 people in every 100,000 that it infects. I'm sorry, 17 deaths per every 1,000 it infects. So 17 divided by 100,000 times 100 means that it has a kill rate of 0.017%. But if you talk about millions of people being infected, that means for every million people that the flu infects, let me make sure that's correct. Yeah, that's not wrong. For every million people that the flu infects, it kills 17,000. It's just that, that doesn't really affect you in your everyday life unless you happen to know one of those unlucky people each year.
So does corona have a higher kill rate?
It does, yeah. And it goes up quicker with age than regular flu does. I actually have a thing that you could listen to if you want to be smart about this, because everybody needs to be smart about this in the coming days and know that you weren't sent home just for fun. There's a really good podcast I like called Science Versus. And also, if you look back to the posting on Google Classroom from the weekend, there's that like 3-part update that I posted. One of those videos is a 3 blue, 1 brown video. He does math YouTube videos. He has a video that explains the math of this in way more detail than I just did. And if you want, so that's the math. You should watch that YouTube video to get your math understanding of what's happening. And Science Versus is a really good science podcast run by this like Australian lady who lives in Brooklyn. That podcast is excellent. In the most recent episode, just like all other science, like internet content, everybody's now talking about this like global emergency. She does a really good breakdown of the science. It's not like panicky the way that the cable news talks about it. It's just very straight to facts, very sober description of what's going on, because it is an emergency and that can't be overemphasized. So like the people who are going about their daily lives like everything is normal, those people are being irresponsible.
Didn't they give someone a vaccine for it?
A vaccine is currently being tested. But even if the vaccine test goes well, which it's hard to say that that will definitely be the case, the test itself will probably take weeks or months, and then they have to replicate it. They have to show that you get the same results with another group, which will take additional months. And then it has to go into mass production, which will take additional months. So even if there is a lab that is on the way to a vaccine right now, we're still months away of this type of social isolation living before the vaccine is made widely available. And even then, you know, it's going to go to medical professionals first before it's then available to the general public.
So who won't, like, are there people that won't be financially affected by this? Like it won't touch them?
That's a different question that I probably can't get into. That's even more complicated than just the science of how viral infections spread and math. Simple answer, no. This is going to affect the entire economy, and not just ours, but global. The global economy is currently being affected by this. That's a separate question that I don't have as clear and concise answers to.
Okay. Bye, Mr. Robinson.
Peace. We have about another 10 minutes of homework time in case y'all want to keep working. But like I said, for the 4 of y'all left in the chat who haven't quite uploaded the homework yet, Science Versus, excellent podcast. Highly recommended. Highly recommended. And since we're all stuck at home, like for indefinite time, podcasts are pretty nice, man. It's a good way to learn a bunch of interesting stuff.
So is like going hiking like safe? Like it's fine?
First and foremost, I'm not a doctor. However, at the time being, I am still going on my runs, but when I go on my runs, I maintain a large distance of separation between me and other people on the street. Though even the science about that is fishy. Depending on who you're asking and what's going on, that radius is either overkill or that radius is not large enough. So like I still need to go out and get exercise just so that I don't get cabin fever or whatever, like how you kind of go crazy from being stuck indoors for too long. But I wouldn't recommend it. If you do happen to go outside for hiking or running, make sure that when you pass people, you keep a large distance around yourself. And I have found that the overwhelming majority of people who are out getting exercise by those means are doing that. Like, I don't have to dodge everybody. People are taking the effort to also dodge me.
How do you know that the virus started from someone eating a bat?
We don't know that. We know that the virus started in bats, though, either eating a bat or butchering a bat, or like if you got a bat trapped in your house or whatever, which I don't know if that's ever happened to you, but that happened to me once at UCLA, and it like sucked. We had to like throw a t-shirt on it to get it out of the dorms. Any interaction with a bat can give it to you, and that's because certain pathologies can exist in animal populations, and that makes that disease impossible to get rid of. So on one hand, you have polio, which basically doesn't exist anymore because it can only infect humans. and we have an effective vaccine for it. So there will be a day in the near future where there is zero polio on Earth, because if you eliminate it in all humans, you eliminate it everywhere. However, like y'all read the Bible, right? Y'all know the biblical disease leprosy. So that's a real disease. We have treatments for it. So if you get leprosy, it's not that big of a deal. You don't fall apart the way that people did like back in the biblical days. However, armadillos have leprosy. So even if we eliminated leprosy in all humans everywhere, if one person like has an armadillo in their garden one day and they grab it just to throw it out of their garden, that simple interaction could give that person leprosy, and you could then have an explosion of leprosy in the human population around that person. So if a disease is unique to humans, we can eradicate it. If a disease is not unique to humans, you could never eradicate it. That's a really good question.
What's the answer
Thanks.
to 4 on page 26?
The answer to 4 on page 26 is no. The two proportions are not equal.
Oh.
Do you see why that is?
But not really.
So it's because of the way that those lengths are labeled. So if you just take the numbers given at face value and divide them, you will get that 1/3 is equal to 1/3. But let's draw it out real quick so that we could be real clear about what proportions we could take. So I have A, B, C, and then inside it, I have an extra segment, DE. And so the given information, I'm sorry, we're doing 4, right?
Yeah.
Okay. So here for question 4, BD is 9. So BD, this guy here is 9. And the trick is that BA, this total length here, that's 27. But what it's telling us is that CE, this part here, divided by EA, this part here, that would give us 1/3. So if this was B, then this would be 3B. Is that okay?
Not really. I don't get how you got 3B and B.
It's not telling us what CE and EA are. Instead, it's giving them as a ratio. And notice it's saying that CE divided by EA is equal to 1/3. And these right here are just dummy variables that I'm picking to help me think about this, because I know that if I say B divided by 3B, well, B over 3B gives me back 1/3 the way that I want it to. So those are just placeholders. Since I don't know how long those lengths are, I just have the ratio.
Oh, okay, I got it.
Is that okay?
Yeah.
Okay, so what it's saying here is that B divided by 3B gives me 1/3. But what does that proportion look like over here? So what's this length?
18.
That's the ticket. This is 18. So if I set up this proportion on top, 9 over 18 would have to be equal to B over 3B. And it's not true, because 9 over 18 is 1/2, whereas on the other side, B over 3B is 1/3. 1/2 doesn't equal 1/3. So
okay.
It's a really good question. They are trying to trick you, because if you just take the numbers at face value, this ratio is 1/3, but that's not what the segments describe. Always start off by drawing a picture.
Oh, okay.
Okay. Well, that basically takes us to the end of our time. So if y'all have any more questions, I'll be sure to get those in now. I'll be shutting this down in about 4 minutes, and then I'm going to learn how to edit a video, and then I'll post it on YouTube. Which I guess I can start researching now.
What's the answer to 6 on page 26?
Oh, that's the question that Manu asked. The answer ended up being 15.
Oh,
Want me to go over why one more time? It'll go up on YouTube, so it'll be up again. But do you want me to go back to that last diagram?
oh yeah.
So the trick to that question is JH is a mid segment, and what that means is that it is connecting the midpoint on this side and the midpoint on this side.
Okay.
So that means the length on each side of J is congruent, the length on each side of H is congruent, and that's giving us two similar triangles, this little triangle to this big triangle. Those two have to be similar to each other. And since this is congruent to that, this would be 2B, this would be B. What's the scale factor?
2.
Yeah, 2 to 1. And that's how we can easily know that, yo, if this whole length is 30, this is 2 to 1, so the little one's got to be 15.
Oh, okay.
Okay. So that's the end of class. I will see y'all tomorrow, and when we re-meet back up tomorrow, we're going to talk about what the quizzes for this class are going to look like. So I'll be putting together some questions to make a quick review assignment for y'all, and we'll do it live just so that we can get used to what testing at home will be like while we're all practicing social distancing. Like I said, keep y'all's minds active, try and get some exercise if you can, and I'll see you tomorrow.
Thank
Okay,
you.
see you. Thanks.
Mm-hmm.